Hey everybody, today we're going to be doing the 12.06 notes on conditional probability. Okay, so conditional probability is the probability of event A multiplied by the probability of event B given, that's the key word there, that event A has occurred. Okay, so this is assuming that when you're looking at two events, that one event has already happened. So you are given that one event has happened. I want to know what's the probability that the next event is going to happen after that first event has happened. So we're going to be using a formula that is on your formula sheet. And so this is going to be the probability of A given B, that's how you read this. A given B is just a vertical line. So when you see that vertical line, you know you're going to be doing a conditional probability problem, a given problem. So the probability of A given B is going to be equal to the probability of A and B over the probability of B. So to find the probability of A given B, you're going to find the probability of A and B, and then divide it by just the probability of B. You just want to make sure that whatever is listed here, A given B, whatever is given, that is what you are dividing by. So anytime that you are setting up an equation, you need to make sure that whatever is listed here, what is given, has to be in the bottom of your fraction. Okay. So boys and girls were surveyed about which shoe styles they prefer. The results are given in the contingency table below. If one student is selected, we want to find the probability of each. So a lot of these problems we've already done. It's a little bit of a review. So what's the probability that someone picks slides? That would be 9 out of, what's our grand total? Remember that this cell is our grand total that's going in our denominator. And then make sure that you can't reduce that. 9 over 20 won't reduce. So that is our answer. Now we want to find the probability of a girl. That's going to be 10 out of 20. That reduces to 1/2. Okay, slides and girl, both of these happening at the same time. So slides are here. Girls are here, they overlap at 7. So 7 out of 20 is our answer. Slides and sneakers. So these will be the probability of someone picking slides and sneakers. What will we do here? So take a second and try to answer this question on your own. See if you can answer. It's a little bit of a trick question. So think to yourself, can one person have slides and sneakers at the same time in this table? Since slides and sneakers don't overlap, there are no people who are picking slides and sneakers. This probability is actually 0. It can't happen for this survey for someone to pick slides and sneakers because there is no overlap in that table. Okay, or, remember, or we add and then subtract. So first we want to find the probability of slides, that's 9 out of 20, plus the probability of sneakers, that's 11 out of 20, minus, don't forget that minus, the probability of slides and sneakers. Can slides and sneakers happen at the same time? We just talked about how they can't, so we are subtracting 0. So that gives us 20 out of 20, which reduces to 1. I mean, somebody in this survey had to pick slides or sneakers. It's guaranteed to happen. They have to pick one. Okay, slides or girl. Remember, we add and then subtract. That's going to be 9 out of 20 for the slides, plus 10 out of 20 for the girls, minus how many girls also picked slides. That would be 7. We're going to subtract that. So that gives us 19 minus 7, that's 12 out of 20, which reduces to 4 out of 5. What did I pick 4? I meant 3. 3 out of 5. There we go. Okay, finally to the new stuff. Girls given slides. So remember that vertical line here. Let me get a little closer so you can see since this is new. Girls given slides is what this says. So remember, from using your formula at the top, we're going to put the and on top, and what is given goes on the bottom. So just to write this out for you, you don't have to do this every time. We want the probability of getting a girl and slides on the top over the probability of what is given. Slides are given, so we're dividing that by the probability of slides. So girls and slides, that's going to be 7 people out of 20. I'm going to do it right here. Divided by, remember that's the same thing as the probability of just slides. So that would be 9 out of 20. Now you can put this in your calculator if you want. Remember, that's the same thing. This is girl and slides divided by slides, so we could write it this way if we want. Make sure the and is first, and then what is given is second. Now, remember that how would you solve a division problem with fractions? Remember, you keep the first one the same, change to multiplication, and then flip that second fraction. Keep, change, flip, and then you can multiply. Or you can just put that in your calculator, but this is kind of a little bit of a shortcut, I think. So now you notice you have a 20 on the top and the bottom. That means we're multiplying by a 20 and dividing by a 20, so those are going to cancel. So our answer is a 7 on the top and a 9 on the bottom. In my opinion, it's a little bit faster than stopping to go type it into the calculator. So this is the probability of girls given that we already know they picked slides. Now there's a way to check yourself with tables, and this only works with tables. When you have a given problem, what that means is you no longer are using that grand total of 20. Instead, you are given slides. That means we already are only looking at the people with slides. So in this case, that means that we can narrow this down to just this column, just the slides column. So instead of our total being 20, our total is now 9 for the slides, which is what we wrote down here. Our denominator is 9. Now, out of given slides, out of the people who have slides, how many people are girls? That would be 7 out of the 9 people with slides are girls. And if you look, that is our answer. So with tables, you can actually do that shortcut, or you can use this formula. Now, on the problems we're about to do next, we're going to have to use this formula every time, so I was going to go ahead and show it to you. But when you do have a table, there is a little bit of a shortcut. Whatever is given is now your denominator, so slides is our denominator, 9 is our denominator. Out of just those people, how many were girls? 7 of them were girls, 7 out of 9. That's our answer. So I'm going to use this shortcut for the next problem just to show it to you. So slides given girl. Now again, you could use this formula, our and on top. Given girl would be on the bottom. But since we have a contingency table, I'm going to use the shortcut. So girl is now our denominator. So we have 10 girls. That's my denominator. Out of just those 10 girls, How many of them wore slides? That is 7. Now notice on G and H, it did make a difference. So we're talking about the same two things. We're talking about slides and girls, but they're listed in a different order. First we had girl given slides. Now we have slides given girl. So even though we're using the same two things that we're talking about, the order for the given does matter, and it is going to affect your answer. So make sure you are doing it correctly. Whatever is given is your denominator. It has to be the denominator because it will affect your answer if you do it the wrong way. Okay, let's go on to example 2 and 3. We have some word problems. Here we are going to have to use our formula that we learned. There is no shortcut unless we have a table. Okay, so in New York State, 48% of all teenagers own a skateboard, 42% of all teenagers own rollerblades, and 39% of all teenagers own a skateboard and rollerblades. What's the probability that a teenager owns rollerblades given that the teenager owns a skateboard? So the key word here, how you know you're going to use this formula, is you're going to see that word given. Anytime you see that given, you have to use that formula that I gave you at the beginning. It's at the top of our paper, and it's also on your formula sheet. So here, we want to know what's the probability of, I'm just going to use a shortcut, rollerblades given a skateboard. Because that's the way it was listed in our problem. Rollerblades given a skateboard. So using our formula, we want rollerblades and skateboard on the top, and what goes on the bottom, it's got to be what's given. So given skateboard, skateboard has to be on the bottom. And now we can just set this up. Pick out in your problem, where did it say rollerblades and skateboard? 39% of all teenagers own a skateboard and rollerblades, so that 39% is going to go on the top. And then on the bottom, that's the probability of just a skateboard. 48% of all teenagers own a skateboard. That 48% is going on the bottom. Okay, and now you can reduce that. 39 out of 48. That reduces to 13 out of 16. And there you go. Now, let's say, what if it asks what percentage of teenagers own a skateboard? Now, we know the probability is 13 over 16. If we want to change that to a percentage, how would we do that? So you can press that little arrow button, and it's going to change it to a decimal, but that's not our answer. We would then need to multiply this by 100 to change that decimal to a percentage. So about 81.25% of teenagers own a rollerblade, given that we know that they already own a skateboard. So 81% of skateboard owned teenagers also own a rollerblade. Okay, in example 3, at a middle school, 18% of all students play football and basketball. 45% of all students play basketball. 32% of all students play football. If a student is randomly selected, what is the probability that the students play football given that the student does not play basketball? So let's set this up. Make sure you notice that keyword not there. So we want the probability of football given not basketball. So remember on the top, that's going to be and, football and not basketball. And then what's going to go on the bottom? What is given? Not basketball. Okay, so first we want football and not basketball. At a middle school, it says 18% of all students play football and basketball. Is that our and that we are looking for? It is not the and that we are looking for. So what I would do in this case is draw a Venn diagram. Okay, so this side's going to be football and this side's going to be basketball. We know 18% of all students play football and basketball. That's going to go in the middle. 45% of all students play basketball. Remember, that's the whole circle. Everything inside that circle needs to add up to 45. So I can take 45 and subtract 18. That means 27% of students play basketball. I'm going to cross out that 45 so it doesn't confuse me later. Next, 32% of all students play football. Remember, that's everything inside of the football circle, including that 18. So if we subtract 32 minus 18, that gives us 14% play football. And so who would be not? Who's going to go on the outside? So remember, this is percentages, so everything should add up to 100. So 100 minus 14 minus 18 minus 27. That means 41% do not play either. Okay, so who will be the students who play football and not basketball? So they have to play football, so they have to belong in this circle, but not basketball. So these 18 people are also playing basketball. We don't want to include them. So football and not basketball, that's going to be this 14% here. They play football and also not basketball. Okay, so on the bottom, we want the probability of not basketball. Now, I know some people are going to be really quick to also write down that 14, but that's not everybody who does not play basketball. If people do play basketball, they will belong to this circle. So that means everybody who does not play basketball has to be outside of that circle. It's not just this 14, it's also this 41. So the probability, just to make a note of it, of not basketball is going to be that 14 out of 100 plus that 41 out of 100. That's 55 out of 100, or that 55%. Ran off paper. That 55% of people do not play basketball at all because they are not inside of that circle. So that 55 is what goes on the bottom. Now let's double check, see if it reduces. It does not reduce. So that is our answer. If you have any questions, message me on Remind, and we can talk it through. We can also set up a meeting time for us to meet on Teams. If you need a little bit of extra help, just let me know. Okay, see you next week.